Hello and welcome to my talk, Mutation Testing, Who Tests the Testers? So a bit about me, I work at the Met Office as a scientific software engineer, which is like an RSE but with off by one error. And fun fact is I have 24 musical instruments. That number kept changing as I went, oh no, I've forgotten that one. So what is mutation testing? It's a way of evaluating your tests to see if there's any weaknesses in them, if they're doing what you think they should be doing. The idea was proposed in 1971, but it's a lot more popular now that you've got more compute power. And the basic idea is you make a mutant by changing a line of code. That could be anything like changing a true to a false, a plus to a minus, or just changing a number or a string slightly, running your tests again and seeing if it fails, which is then known as killing the mutant. So you want them to fail each time you make that change. It has some similarities to coverage, but it's different because it's actually running those lines of code rather than just like a box-ticking episode of, yep, that one's ran, that one's ran. So it has some differences, and it's more fun. So what is the basic mutation testing workflow? First of all, you want to verify your tests and timings, because you want them to know they are working in the first place. And then the timings is so you can realize if it's something that got stuck in an infinite loop or something else has happened. Then you want to make a mutant by changing a true to a false maybe. After that, you want to try and kill the mutant by running your tests and expecting them and seeing if they fail. If they don't, you then have the option of either improving your tests or going on and going back to step 2 and making a new mutant. And I've just realized that for the next step, I need to quickly grab my cards, but we'll do the next slide first. So there are a load of different mutation testing frameworks. I'm going to be using MutMut. It's the one that was easiest for me in Python. Cosmic Ray does a lot more. I have also used that one since, doing a lot of this learning. And there's a repo there if you want to look at a huge list of different ones in different languages. So now we're going to go to the code. Oh no, my bag first, because... And now we're going to do some live coding. Well, not coding, just bash. But yeah, we're going to... So, let me just find where we got up to. So we have it's not... Oh, I should have learned from the mistake was made earlier with that. There we go. Yeah. So we have a number of, that's not the right first one. So we have a number of just like regularist functions here, which do what you'd expect them to do, and then some tests. These tests were either written by me with some weaknesses in that to highlight things, or ones that Copilot or ChatGPT have given me, because that's definitely an argument, an argument people give for ChatGPT being, oh, it's excellent writing tests, is something I've heard a number of times. And so here's some fun things I found it still does as a mistake. So as I mentioned coverage earlier, we can do a coverage report and see that is 100% on all of them apart from the prime example, which I'll show you in a bit. But I'm sure once we get there, everyone will hopefully be able to see what was wrong with those ones. And now we can look at the outcome of running mutation testing. So I've already ran this earlier, it's been cached. And we have lots that have been killed, but a load that so load that have survived. About 50%, I think, is the amount here because I was trying to find ones that were failing. So let's quickly look. Is this big enough? Oh, there we go. So let's quickly look at the first example. This is one that a mutant that was killed, where it's changing a plus to a minus with this git diff of it. So the red is the line that's been taken away, and the green is the line that's been added. So that mutant's been killed because in the tests, 2 minus 2 doesn't equal 4, because originally it was 2 plus 2 equals 4. Some other examples of some mutants in here are times being changed into a divide, or equals being changed into a doesn't equals. And again, these have all been killed by the tests because they're just picked up by one of these will at least find that problem and go, no, that doesn't make sense. So now let's look at an example where it wasn't killed. This is one where it's added x's to either side of the string, and it wasn't picked up because of the testing is only checking for just if an error was raised rather than what the error was. So to fix this, you just need to expand the texting to add a regex in it. Now the next two is a great way of highlighting the testing of edge cases. So 7 here changes the less than equals to into a less than, and 8 is the same but with the next set of less than 2 or equals to. So this is because these tests didn't hit all those edge cases. And this is a simple toy example, but once you have something that starts getting sort of big and ugly, these examples are really, these sort of tests are really good at highlighting some of those things. So we can actually fix that with a ChatGPT. So we can add that in, and now we can run the mutation testing again, and this will apply that mutant, the mutant that failed earlier, and try and kill it again. And due to the change of adding in something that'll hit the edge cases on the middle, it's killed it. So that's good. And you get to say killed a mutant, which I think is a really good part about this. So the next bit I'm going to show you is this prime function. So it just works out if a number's prime or not. And these tests were all given by ChatGPT when I said I wanted a function that did this and some tests for it. And it's given me loads of, tests for prime numbers. Didn't give me any tests for non-prime numbers though. So it's a good learning tool for that. So with this, we had a few different failures in this whole one, but the big one here is where the false has been changed into a true, but that was never actually hit because we never tried any numbers smaller than 1 or smaller. So that could, again, just be fixed with some more. The next example is using NumPy. This is an array. This takes an array and multiplies it by a number. I base this off the fact that I've seen mp.ones, which generates an array just full of ones, and people have used that just to make a nice little bit of data to run their tests on. But with this example, both times, because it's being multiplied by 1, once the mutant changes the multiply to divide, it's then getting the same answer. And that's the sort of thing I've seen before where people have seen a bit of code and gone, oh yeah, that's a good way of doing that. Sort of copying it across and maybe not thinking it through properly. And the last example is for Iris. So Iris is a meteorological data Python library that reads netcdf files. And so it's NumPy in the bottom with a lot of metadata. And this is an example from a repository I work on. And we have this change attribute where we're adding a history to this, and the tests have cared all about what the data itself is doing and never actually tries to assert the other change you've made in the code. And for the job I do in the Met Office, we care a lot about the metadata that we're outputting. So we should make sure that probably gets tested. So the mutant itself is, you change the string to a none, and then when it's ran, we haven't actually done those tests, so it highlighted that. The repo is there if you want to have a look at it and try and fix all the tests yourself. So in summary, it's a great way of looking at a repository and finding some weaknesses in the code. And it's really good at showing sort of some slightly more odd edge cases as a functional class has grown. And it's a good teaching tool for that reason too. And some cons are it can be really slow. The main repo we use, it takes 24 hours to run everything on, but it can be parallelized, but it hasn't been done with. Any questions? Let's
see if the questions are coming in. Can you get them? Are there no questions so far? So, I have a question. What's an example of a false positive?
I didn't mention that bit. So the false positives I found, there was an example there that I didn't include in the end, where in the prime number example, it went to, I can't remember the exact, it used to the power of, and that was changed to a multiply, and that then it still got the right answer, but having the to the power of meant it was more efficient because it was able to give up and go, yeah, this is a prime number. So to make that work, you had to have like a number that was like 41 trillion, I think, that had to be that big for it to then go, oh, this has taken too long, something isn't correct. But there's some things in there where it's not really a problem, but sort of is.
Yeah, that's interesting. And we've got a question here from Andrew Lister who's saying, how often do you run this if it's too slow?
I've not been able to put it into GitHub Actions for that reason. I think you could do it on just the code that's been changed, but so for what I've been doing is just been slowly going through everything sort of file by file as like a Friday afternoon fun project to just to improve our code base.
Okay. And then we've got another question from Sebastian James. I'll ask you, Sebastian, in the room. Yeah, there you go.
Mutation, but my phone got it wrong.
Okay.
Yes, yeah. So normally it's you change one line of code, you then run through everything, you try and kill it, and
does the system choose what mutation to make? Does it just sort of randomly choose?
It'll just systematically work through everything in the code base, every single line of code. It will try and change everything. So it is very parallelizable if you've got enough memory and.
So it will try and change everything it can try in one test.
No. So it'll make a change, run through everything, then change that one back, make a new change, and go through.
So the number of mutations is dependent on the kind of the length of the code.
Yes. So there's 4,000. Yeah, it's 4,000 mutations in the one that I said takes 24 hours, whereas we had 30 in this nice little example.